Hello, and welcome to Franco and Rakan's Physics Fun Time. Today we will be discussing electric field mapping. First, let's start off by talking about the materials needed for this lab. You will need a metal conducting plate, conducting graph paper, a voltmeter, two cables with magnetic ends to connect to the metal plate, a metal conducting bar, which will only be used for part 2 of the lab, and finally, a power source. Alright, so let's set up the experiment. First, we will connect one of the cables to the positive outlet of the power source, and then place it at a fixed point on the metal sheet. We will then connect the output cable of the voltmeter and the other magnetic cable to the negative end of the battery. Then put the end of the magnetic cable at a fixed point on the metal sheet, perfectly opposing the other magnet. Now we will be setting the battery to 5 volts and turning this bad boy on and getting this experiment started. What we want to do is find a certain point on the metal sheet where the electric potential difference is 1 volt and record its coordinates on a piece of graph paper. Then we will find another point on the metal sheet where the potential difference is also 1 volt and record its coordinates also. We repeat this step about 5 times so that we have multiple coordinates for the 1 volt potential difference. After we have our coordinates, we will be moving on to a different potential difference. In this case, we will be finding coordinates for the 2 volt potential difference. So we find where the potential difference is at 2 volts, and then we find a few other coordinates on the sheet where the potential difference is also 2 volts. We will then be doing these steps again for a potential difference of 2.5 volts. Then we repeat once again for the 3 volt potential difference. And once again for the 4 volt potential difference. After we have gathered all our coordinates from various potential differences and have plotted them on a graph, we need to connect the coordinates for each of the potential differences. Do not connect the dots as if it's a kid's coloring book. Instead, draw somewhat of a parabolic line that intersects with all the coordinates for that potential difference. These are the equipotential lines. You will then need to draw electric field lines coming out of the charges, intersecting the equipotential lines perpendicularly. You also need to add a brief explanation about the theory of this experiment. In this case, the theory involves the electric field and equipotential lines. In this 2-point charge system, the lines will connect the charges together. The electric field goes from the positive charge towards the negative charge. When drawing the electric field lines, make sure they intersect the equipotential lines perpendicularly. For part 2 of the lab, we challenge you to find the electric field of the setup shown, using the previous procedure. Hope you enjoyed the video. Thanks for watching!